Welcome everyone. This is Serverless Scala functions as super
duper
micro
service
is.
Yes. We came up with a name. Can you tell?
Yep. Yeah, that was all ours. All ours. I'm James Ward. I'm a developer advocate at Google.
I'm Josh Suereth. I'm a staff software engineer at Google.
Yes. Okay. So we're going to talk first about serverless, what it is, well, what we think it is, and then we're going to dive into some code and talk about architecture and all that kind of good stuff. So first, serverless. What is serverless? So serverless, the way I like to think about it is that it's pay for what you use managed hosting. So it's managed for you. You shouldn't have to manage the stuff. Like you just deploy it and it runs, and you don't have to think about the operations and all that kind of stuff. And then it's pay for what you use, which ultimately means we're trying to match the demand on our application with the supply. So you could imagine that if you left a bunch of servers running and they weren't being used, then either your cost would have to be really high to account for that, or you would just want to shut down those things when they're not being used. And so this is, I think, a core part of serverless, is being able to turn things down when they're not being used easily and having your applications account for that ability so that they can be turned off when they're not being used. You might be thinking, like, what if I'm not using a cloud provider? I've got some on-prem stuff and I am not paying for things. Like, we paid for our servers long ago, and so I'm not actually paying for these things. What does it mean in that world? And what I look at that as is that Netflix calls something a trough. So they have this whole thing where when you're not using your resources in their infrastructure, you can return those resources to the trough. And then other jobs that aren't user critical, don't have the expectation of time, like how long it's going to take to run them, they can pull resources out of the trough. So this is like machine learning training stuff can be pulled out of the trough and used that way. So even if you're on-prem, you've bought your servers, I think this still works because you still may want to return those resources to some place that they can be used for other things when you're not using them.
Yeah, it's recycling your headroom.
Recycling your headroom, that's right. So you can imagine, you've paid for all these servers if you're on-prem, and you want to return them to the trough. It's actually a great way to make money on Bitcoin. So all of y'all should be able to get rich by all the slack capacity in your on-prem servers, right? If you go serverless. And send me a little cut, please. I could use that. Okay. There's a few different flavors of serverless that have come out. There's function as a service, and so this is where you deploy a function and it goes into this managed mode, and then it'll spin up the resources required to run that function when requests come in or when you need to process some job or whatever it may be. But it's at the granularity is at the function level. And then there's platform as a service, which is really about deploying applications. And platform as a service can also be serverless. You're just shutting down a whole application instead of just a little function. Okay, so that's our quick little kind of thoughts on serverless. And we're going to do more thoughts on serverless in the panel tonight, so you should come to that. That's going to be fun.
What were our thoughts on serverless again?
Pay for what you use.
Oh, and?
Managed. That's right.
Yeah.
Why were those highlighted after the fact?
After we just walked through them?
Yep.
To reinforce the point.
That's right.
Right? Yeah.
I think that was a bug in our slides. I think we're supposed to highlight those.
We don't want you to remember anything from the slides.
My
so
slides
ignore
are
those
serverless.
underlines.
Yeah, my slides are serverless.
That's good.
Yeah.
That's good. We should talk about Cloud Run.
So for our demo later, we're going to be using something called Cloud Run, which is serverless for containers. So it's not function as a service per se. It's anything that you can run in a container. So I have a little example where I run Netcat in a container. It's like the lightest weight little web server you've ever seen. It's pretty awesome. So Cloud Run, that's what we're going to be using. But Cloud Run is based on an open source project called Knative. And we just did a workshop yesterday on that. If you were there, it was awesome. Well, I thought it was awesome because everything
awesome.
worked. Josh was there. You were there too.
Yeah, I was there.
Yep. So we did it all on Knative. And so Knative, if you're looking for something serverless on top of Kubernetes, that's Knative. And yeah. Okay, so oftentimes when you are learning about serverless, you are using serverless, you run into something called cold starts. And this is like the most like contentious part of serverless is, oh, you're going to get cold starts. The problem with what cold starts are is because you have to shut these things down when you're not using them, what happens when you need to use them? You need to start them back up, right? And so this takes time to start up things. And so when that time that's being taken is called a cold start. And so we wanted to talk a little bit about some strategies for dealing with cold starts. So it's because we're scaling to zero. Actually, it's not. My slide is. What's wrong with these slides? It's not just about scaling to zero. Because what if you are at 1 and you need to go to 2? Then you get a cold start there.
Then you still have a cold start. Yeah. So the way to think about cold starts is more about you're trading money for your 99th percentile latency, right? Do I want more money, or do I want a better 99th percentile latency? 99th percentile latency would be 99% of my requests are served in a certain amount of time. Every once in a while when I have to boot up a new machine, right, that request is going to get really slow, possibly embarrassingly slow depending on the service. So not every service you can trade, that latency for money, but sometimes you can.
Yeah. So for example, if you're building like a voice system that's supposed to like respond, it would be really weird if it didn't respond immediately. That would just be a weird experience. Or if like somebody's like checking out of a shopping cart and it takes a while, they may just like go and do something else and cancel their order, and you don't want that. So some jobs are very sensitive to cold starts, and then other things like ETL jobs, not so sensitive to it. So sometimes it's an issue, sometimes it's not. So one of the ways that you can deal with cold starts is just try to reduce your startup time that it takes to go from nothing to something. And there's some strategies for how to do that. If you're in the Node world, they're like, oh, keep your like Node application under 5 megabytes, and then like it magically will start up quickly every single time. And then you're like, what about database connection pools? And then they're like, well, we're serverless, so we don't have any database connection pools. Then you're like, okay, well, that's going to take a long time to connect to the database on every request. Anyways, so it's sometimes you can reduce your startup time and deal with some of the problems. But then what if you have to like warm up a cache on your system? That's something that you just can't deal with that. Sometimes you just need warm stuff. And so yeah, that can be hard. If you're on the JVM, if you're programming on the JVM, I expect most of you are Scala developers here, then you may be able to use GraalVM, which is an ahead-of-time compiler which compiles down to a native binary, which allows you to start up much faster. And so this is a great option. That's actually what we used for the demo that we're going to show you in a little bit, is GraalVM with Zio.
Yeah, and one of the important things about GraalVM is you're trading consistent latency for potentially optimal throughput, right? So JVM servers meant to sit there a long time, take a long time to JIT, and then they get to their efficient world, and it takes a while to get there. With GraalVM, you get this nice consistent startup time and a consistent serving path, right? But you might not get the same optimal performance. So again, there's a trade-off, and in this case, it fits really well with that same serverless trade-off, right? I get that consistency I need to know how to scale.
So I use SBT a lot. You helped with that project a little bit.
Yeah, a little bit. Yeah.
And I don't use the console on SBT very much. So usually when I use SBT, I'm getting a cold start on SBT, right?
Every time.
Yeah, but somebody has taken SBT and run it through GraalVM and produced an SBT binary that starts up just instantly.
Wow.
Yeah, no more cold starts, even for your dev tools.
Oh, man.
Amazing.
The whole SBT server thing, by the way, was to avoid cold starts ever on your machine. Most of the development in SBT for like the past 3 years or so was to like keep it persistent always, and just sucking up all the RAM on your machine so that your fan would turn on, and then also make sure that it was fast. Yeah.
Just trade-offs. It's all about trade-offs. Okay. So transitioning out of serverless, we're going to talk about building server apps. Let's talk about the way that I've built a lot of Scala server apps.
All right.
Is with Play Framework, where it's so nice because you just like have a function that has a request as a parameter and returns a response. Like so simple. I love it. But
what do you have to pass into there?
Yeah, that's hidden. No, see, you don't. There's nothing there. It's
magic. It's implicit. It's magic.
Okay. It's implicit.
Okay. Cool.
It's implicit.
Cool. There's nothing else.
That's right.
Oh,
there's a lot of stuff lurking under the covers that you actually need in order to be able to take a request, and return a response.
Yeah, so this is where we're talking about dealing with how to do threading, where we pull our configuration from, how to serialize things. It uses actors under the covers, so how we instantiate actors and push them around. Right? There's a lot of context in that little bit of code that's hidden from you. You don't see it, but it's there. And so when I need to test this,
yeah, when you need to test this, man, it gets a little tricky.
Yeah.
It's a little tricky because then you have to recreate all those things that were providing that information to be able to handle that request. And Plays tried to make that a little bit better with this with application thing, and but it takes a while to run your test because of this and all sorts of stuff. So
yeah, you might be booting up a little mini Play application every single time you want to unit test a little tiny bit of your code.
Right?
Yeah,
that's a lot. That's a lot going on. So the question for us is we've built a lot of server apps and tried to think about, okay, how do we go through the different cycles of a server app from dev to test to prod? Is there a better way? Is there a better model to be able to move between those environments without having to have all this kind of stuff needed around my actual logic that I'm trying to test?
Yeah, specifically that function, right? It's not going to run on just a web server in production and then your unit test, right? You're probably going to do a little bit of testing across components, especially with microservices. You have a lot of these services, and one thing we do is, I don't know if I coined this term, so I don't know if this is a real term, but I call it edge testing, right? You test your microservice to its dependency microservices. You start those up. You make sure that they can communicate together, but you stub everything else out, right? And you do this because you need an integration test, but you might have hundreds of microservices. You don't want to stand up all 100 microservices or run your test in production because of some instability issues or possibly corruption of data and all that kind of stuff. So instead, you'd really like to try to do some edge testing here between the things. And so you have all of these different environments that you're taking this code and pushing it into. And you're not going to have one config file for the production config. You're going to have production. You're going to have integration testing. You might have a QA environment. All sorts of things that you have to put this code into. And they're all subtly different environments.
Yeah. It's tricky. It's tricky.
Yeah. So we want to move from write once, run anywhere to write once, run everywhere, right? All of these environments. I need to not just run on one at a time. I need to run on all of them and adapt to them.
Yeah. Yeah. So how do we do that?
Well, I think we need to focus our logic, right? When I'm in development, what do I care about?
Just the logic.
The business.
Yeah.
Yeah.
The business domain.
Right. But when I'm going to production,
transformation.
all I care about is moving JSON from A to B. That's what I care about. Yeah. And then in production, what do I care about? How fast the JSON's moving.
That's right. How quickly can I get that JSON in and out?
And then for testing, is the JSON the right shape?
Yeah.
Does it look like a bunny or does it look like a turtle? I don't know.
We don't know.
But I need to know.
That's why we test.
Yeah.
Yep. Okay, so we wanted to experiment with some of these ideas around this, and so we built an application as an example that is a chatbot, not like the Slack kind. Well, maybe it could actually be a Slack bot. We should do it as a Slack bot.
We could also do a Slack bot, yeah.
But we were like, okay, can we have something that we can just test the actual logic on, just for local development uses, and then can we expose that same logic as different protocols? Let's do standard in, standard out. Why not do telnet? Because, and then, hey, let's write a web server from scratch because that would be fun too.
Yeah. Well, I mean, once you start with telnet, you go all the way, right?
That's right. But the web HTTP is just a little layer on top of telnet, right?
It's true. But yeah, telnet's really easy to test on your system, right? I just telnet into a server and bam, boom, right? I just send text. Good. Cool.
Yep. Easy. Okay, so we built this simple little chat application, which we'll see in a little bit. So we used significant white space in Scala 2, and it was amazing. Isn't that beautiful code? Yeah, we like it.
Horizontal significant white space.
Horizontal significant white space.
Yeah.
It's a new thing.
But this is what the code should look like. This is what we want to focus on for business logic, right? After the user says something, and we've kind of recognized what it is, we have something to kind of interpret it, they've told us a language. And if they tell us a language, then we're going to say whether or not they said the right language. And if they haven't given us a language, if they say anything else, we don't care what it is. We'll just say, hey, what's the best language? And there's only one right answer for this app.
Yeah.
Because it's what it's written in.
That's right. So this is like the logic that we want to write. This is the logic that we want to test. This is like as close as we can get. But
yeah, we can't do that because there's a lot of other things in here that kind of get in the way, right? There's logging, there's monitoring, there's all sorts of little components, that we're going to be adding to this code, and it turns out not to look that simple as we add in all those things.
That's right. Yeah. So enter the interpreter pattern.
Yeah. So what we're going to do is we're going to find a way to write that logic and kind of hide all the other stuff so that our business logic looks as close to that ideal as possible. And we can test that business logic, but we can also put in the little bits that we need that are kind of more horizontal. So here what we're doing is we're constructing a data type called talk, where we have different operations that you can do when you talk, right? So I can say something, I can ask for something, or I can output several different things. I could say and ask for things, okay? So those are the operations that I have. And now, in next, right, I'm returning this like operation that says what you should do, but I don't actually do it, right? So before, we were actually calling a method that would do the talk. Now we're returning something that just, it's just a piece of data, right? It doesn't actually do the behavior. And so all of those little pieces of logic around when I say something, I want to log, how many times I said this thing, or I want to log how many times the user said something, right? All that's hidden and somewhere else. It's not in this logic. I can test it without having to deal with all that extra complexity.
So we can take this meta program that is just our like core logic and the data of that, and then we can wrap around it an interpreter and the environment that then is needed. So in development, we're going to have a different environment, and testing, we're going to have a different one, and production, we'll have a different one, so on and so forth.
Yeah, those of you who have been in Scala for any number of years, you've probably heard this message preached over and over and over and reinvented about a bajillion times in the functional community, right? So these are our projections of what might happen given this timeline. But these are the different ways that this idea has shown up in FP. We've been just reinventing the interpreter pattern in many, many, many different ways. So
we should have made a prediction there. We should have made a prediction on when we're actually going to figure it out.
Yeah, it's true.
Because we just said question mark, question mark.
Well, colonize Mars. I already live on Mars.
That's true. You do.
Yeah. Mars, Pennsylvania. It's a place. Anyway.
Okay, so we used Zio for our effect interpreter, and so let's just talk a little bit about what Zio is, and before we get into a little bit of the code.
Sure. So Zio is there's two ways to describe it, right? There's the glib way that you use when you're trying to be coy, right? And then there's the actual like how you describe it. So I'll give you the glib way first because I just can't help myself. But you just say by functor.io, and then you'd walk away, right? But no, what it really is
You're supposed to drop the mic and walk away. By functor.io.
Oh man. Okay. All right. So what it really is you're trying to encapsulate your program, and you're remembering three things in your program. So you're building up these values that are programs that can execute. And the three things you remember are, what's the environment I need to run this program? Like, what are the components that I need to run it? Do I need a logger? Do I need some kind of monitoring? Do I need access to threading? Like, what's in that environment that I need? That's the first type. The second type is, what errors am I going to return? It actually makes you kind of remember this. It doesn't just make everything throwable. You can pick whatever you want. And the last thing is, what will this program return when it executes? Okay? So that thing where we made that abstract syntax tree, what ZIO gives you is a building block to construct more. And with these three components to it, so you can kind of make applications this way.
And then you essentially can just build a chain of Zios that becomes your full program. But at any point, you can take part of those Zios out and test them independently or provide a different environment to them.
So here's an example where we abstract out that talk ADT that we had before. So here we have a talk service, and in Zio, the way you make an environment is you're going to make something that withs, like trait extension methods into an environment. So you kind of bundle these things together. It has a name, and that name used to terrify Scala developers, so we never used it. But it is called Dependency Injection.
We call it the reader monad now.
Sorry.
That's right.
But okay, it's also the reader monad. That's one of the functors in the bifunctor. Anyway, it's called dependency injection, and this is we're defining a trait which is saying, hey, in that environment type, you need to provide this service, right? If you require this type, and then when you define the service, there's a bit of boilerplate here. It's probably like the grossest part of Zio, honestly, the boilerplate, but it tends to work out. So you define your service, you define your methods on it. They return these Zio instances that you can then compose with everything. And what's interesting is now I can define an application that uses my talk service, and I can take in the type signatures, I can know when I'm using the talk service, and I can provide a talk service to my Zio program and remove the need for it later. So I can basically compose applications where I can decide when I need to instantiate this thing and how it's used, and I can kind of peel on and off my dependencies. It's pretty powerful.
Yeah. So that's what we built, was our talk service, and that's not exactly what it looked like in code, but pretty close, right? Even with the significant horizontal spacing. Yeah. That's how we program all the time now.
Yeah. Significant horizontal space.
Oh,
yeah.
we forgot on the right side. Oh, man.
Oh, right.
But another bug on the slide.
Yeah, we'll fix that. This one doesn't compile. But you can see how this is a lot closer to what we really wanted our business logic to look like, right? And that's the goal, is to make sure the business logic matches the way you think when you're doing business logic. It should not have all of those other things bled in, right? Yep.
Boom.
No, sorry. I wanted to talk about this.
Oh, okay.
Jeez.
I thought it was just like emphasis.
The emphasis here is this program relies on that talk service being provided, right? So I can compose Zio here, but the environment is remembered. So I have a dependency on the talk service for any of this code to be implemented. So if I'm going to test it, if I'm going to run it, I need to provide a talk service. It remembers my dependencies. So I have dependency injection, but the dependency injection is actually type safe. It's remembered throughout the system. And that's actually important, right? If I start using some other Zio services, like blocking, threads, that kind of thing, they will show up in that type signature, and it will be remembered. So it's a really interesting concept to dependency injection.
So then we need to provide an environment to actually run this thing. So we, as I mentioned, we had different protocols that we could use, and so ultimately different environments. So we have a cloud environment that is able to execute the request over HTTP. Then we have the console one, which just does standard out. And we're providing different environments into this thing so that it operates differently. The business logic doesn't change, just the environment that changes around it.
And what's interesting is after you provide the environment, you notice the environment becomes any, because I can run anywhere now. Like I provided all of the necessary services for this thing to execute, so it can just run.
Just run.
And you now have environmental cake. Anyone remember the cake pattern in Scala? Yeah.
Yep.
Also a bad word. Yeah, but it's so this is dependency injection with kind of a cake pattern. You bake this environment together of all the things that are necessary to run that program, and you very clearly and explicitly denote them in your types.
Nice cake. Okay. So if we want to add like monitoring into our business logic, then we can just have something that has monitoring in it, and we can change that monitoring environment, what it's actually doing. So if we're running in production, we're going to send that up to our monitoring system. If we're running locally, we can just make it do nothing if we want. Okay, so what does all this have to do with serverless? So the way that the idea we wanted to experiment with is that we look at Zio and bifunctor IO and all that stuff is allowing us to abstract from the environment that we're running on. And then serverless allows us to abstract from the operations.
I think that's backwards.
Was it backwards?
Serverless is abstracting from the environment. Oh, no, you're right. You're right. My bad.
See, there's a cloud on that one.
I know. Yeah. My bad.
Yeah, and on that one, see the little boxes? It's like the layered environment, the layer cake.
The different places you run.
That's right.
Yeah.
And then we get this beautiful cake in the cloud. Okay. So that was the idea. We talked a little bit about that, being able to change the implementation, change the protocols across the different environments.
Yeah. So the demo, we're going to show you some of the different environments that this code that you were looking at actually runs on. And another interesting thing is it's actually the same binary. We put a little thing that detects what environment it's in, and then instantiates the program correctly, provides the appropriate resources, right? And that's a nice little if-else statement that you can actually read and understand what's going on, as opposed to trying to track through XML or annotations and figure out which one is coming through, right? It's more clear, concise code.
Keep talking. We're getting a cold start.
Oh no.
So we're going to run the console version of this demo, and then we're going to show you the Google Home one as well. Okay, survey says, what's the best programming language? Java? Is that what I heard?
Yeah, I think I heard that.
Wrong.
Oh man.
Okay. Scala is the best programming language. Correct. Okay.
All right.
There's our console version.
Yeah.
Okay.
Beautiful.
Now let's try this one, and I'm going to hold my microphone up so you have to talk.
Oh, okay. Is it on?
It should be on.
Okay, Google. Talk to ZIO language? Zio. Talk to Scala Zio.
Sure. I like talking to you.
No. Hold on, my phone's going off.
Oh, you're fine.
Yeah. Okay, Google. Talk to Scala Zio.
Getting the test version of Scala Zio.
Survey says, what is the best programming language?
Rust?
Wrong. Survey says, what is the best programming language?
Scala?
Say that one more time.
Of course. Canceled.
Hopefully you all heard
That was a little Easter egg for you.
Yep. Nice. Okay, all the code is up on my GitHub if you want to check it out. We have 1 minute left. Any questions?
Does anyone have any questions in the last minute?
Yeah, go ahead.
So in this form, if you were doing the program, what is the worst programming language? Would the correct answer be Java then?
Well, no, so the code is the thing. So the question is, what would the worst programming language be? The code's the thing answering the question, and it's written in Scala, so of course it thinks itself is the best, right? Like it's
That's right.
the code's doing the answer.
It's kind of narcissistic.
We didn't decide that. That was the code. Yeah.
Okay, one more question.
Yeah, I had a quick question. So there was a previous talk by Jason who was like talking about the Gravel VM.
Yeah.
So he said that within the Gravel VM you cannot use libraries that depend on reflections. So how did you guys get around it?
That's right. Yeah. So in GraalVM, you cannot use things that use reflection. There is a way around it. You have to like create a file that talks about the reflection and all that kind of stuff. But in general, yes. Because we're using Scala Zio and not using anything that uses reflection, we didn't have to worry about that. If you look in this repo, there's the Docker file which builds the GraalVM native image. So if you're interested in how we actually built it, then check it out. But definitely one of the interesting things about using libraries that only using libraries that don't use reflection is that they work well in GraalVM. So, yep, good question. Okay, we're out of time, but hopefully that was useful and fun. Thanks so much for coming.
Thank you, everyone.
Thanks.